A man was afraid for more than 20 years. He hid what he wrote, concealed it, showed it to no one. He had knowledge in his hand but could not dare. Why? What had he written that he was so afraid? Was he afraid of the church, the academic world, or something else? This man's story was stuck between courage and fear. Tonight we will discover together the life of Nicolaus Copernicus, the founder of modern astronomy. Don't forget to subscribe to our channel and mention in the comments which city you're following us from. Now let's go to 15th century Europe. Nicolaus Copernicus was born on February 19th, 1473, in the city of Toruń, Poland. His father, Nicolas Kopernik, was a wealthy merchant from Krakow. His mother, Barbara Watzenrode, came from a local noble family. Nicolas was the youngest of 4 siblings, and his childhood was spent in one of Poland's richest trade centers. In 1483, when he was 10 years old, his father passed away. This loss was a great blow to Nicolas and his siblings, but their mother Barbara did not neglect the children's education. More importantly, his uncle Lucas Watzenrode took responsibility for young Nicolas. Lucas was rising in the church hierarchy at that time and would become the future Bishop of Ermland. Lucas Watzenrode was an influential and ambitious clergyman. He gave great importance to his nephew's education and decided to send him to the best schools. The path he set for Nicolas was clear. He would receive a good education, enter a church career, and increase the family's prestige. However, young Nicolas's interests would span a much wider range. In 1491, he enrolled at the University of Krakow. This was Poland's most prestigious educational institution and housed the best teachers of the period. Krakow in those years was one of Europe's important intellectual centers. Here he studied mathematics, astronomy, philosophy, and classics. Especially astronomy classes would change his life. Among his teachers in Krakow, Albert Brudzewski held an important place. Brudzewski taught the traditional Ptolemaic system, but also discussed its problems. The complex epicycle systems used to explain planetary motion contained inconsistencies. Young Copernicus developed his curiosity about celestial motions in these classes. However, some conservative teachers in Krakow were closed to new ideas. Aristotle and Ptolemy were unquestionable authorities. Young students asking critical questions was not welcomed. Copernicus learned to be careful in this environment. Instead of openly expressing his ideas, he preferred to think quietly. After studying in Krakow for 4 years, he left in 1495 without obtaining a degree. His uncle had made bigger plans for him. He would go to Italy and study law. Legal knowledge was essential for a church career, and universities in Italy were Europe's best. In 1496, he went to the University of Bologna. Here he began studying canon law, but his interest in astronomy never diminished. In Bologna, he met Domenico Maria Novara. Novara was one of the period's renowned astronomers, and Copernicus stayed at his house. This period was critical for Copernicus's scientific development. He made observations with Novara, recorded the movements of celestial bodies. In 1497, they observed the moon occult, the star Aldebaran. Such practical work gave Copernicus the opportunity to blend theoretical knowledge with experience. Moreover, Novara was outspoken about the problems of the Ptolemaic system and discussed alternative models. Sometimes they also had disagreements. Novara was more pragmatic and preferred to work within the limits of the existing system. Copernicus was asking more radical questions. Why are planetary motions so complex? Why does nature seem so incomprehensible? Perhaps the problem lies in our perspective. After spending 3 years in Bologna, he went to Rome in 1500. This was a special year for the Church, because it was a Jubilee year. Copernicus gave astronomy lectures in Rome and began to gain recognition. The knowledge and ability he possessed at a young age impressed people. However, some conservative clergymen were uncomfortable with the young scientist's questioning. In 1501, he made a brief return to Poland. He took a canon position at Frombork Cathedral. This position would provide him with income and promised a stable career within the church. However, he did not immediately start the position because he requested permission to continue his education. Some canon members criticized this prolonged education, but his uncle's influence protected Copernicus. In 1501, he returned to Italy and went to Padua to study medicine. In those years, it was customary for church officials to have medical knowledge. Moreover, medicine was closely related to astronomy through astrology. Copernicus studied medicine for 3 years in Padua. Here, he learned human anatomy, disease treatments, herbal medicine. This knowledge would be useful throughout his life. His years in Padua were not limited to medical education. The city was the beating heart of Renaissance thought. Art, science, philosophy. Every field touched each other. New ideas were being born. In this atmosphere, Copernicus gained not only knowledge, but also courage, questioning authorities, critical thinking, relying on evidence. This spirit of the Renaissance deeply influenced him. Other students he met in Padua also came from different disciplines. Mathematicians, physicians, lawyers, philosophers, all discussed together, exchanged ideas. This multidisciplinary environment shaped Copernicus's way of thinking. He learned to look at a problem from different angles. The 7 years in Italy not only equipped Copernicus with knowledge, but also nourished him with the Renaissance spirit's atmosphere of free thought. However, he also knew that this freedom did not exist in the same way in Poland. When he returned, he would need to be more careful. In 1503, he went to Ferrara and received his doctorate in canon law. The 7-year Italian adventure was ending, but these years had not only made him a law and medicine expert, but had also transformed him into a versatile scientist, influenced by Renaissance thought. In 1503, he made a definitive return to Poland. His uncle Lucas had now become Bishop of Ermland, and Copernicus served him as personal physician and advisor. They lived at Heilsberg Castle. Here, Copernicus was performing both medical duties and helping with the bishopric's administrative affairs. The 6 years spent with his uncle were both an intense and productive period for Copernicus. Administrative duties, patient visits, diplomatic meetings. He was very busy, but in his spare time he continued his interest in astronomy. He made observations, carried out calculations, took notes. At night, when everyone was asleep, he watched the stars and thought. Around 1510, he began to outline his first great theory. He was developing a sun-centered model instead of Ptolemy's earth-centered system. This radical idea challenged the cosmology that had been accepted for centuries. During this period, Copernicus was being very careful, sharing his ideas only with close friends. In 1512, his uncle Lucas died. Copernicus moved to Frombork and began his duty as canon of the cathedral. This small city was a quiet place on the Baltic Sea coast. Copernicus lived a relatively comfortable life here. As a canon, his income was guaranteed, and he could use his time as he wished. In Frombork, he set up a small observatory in one of the cathedral's towers. From here, he systematically watched the sky. His equipment was very basic, because the telescope had not yet been invented. He made observations with the naked eye and simple angle measurement instruments. Some nights he waited for hours in freezing cold, showing patience to record a planet's movement. Around 1514, he completed a short manuscript called COPERNICUS. This approximately 40-page text contained the main ideas of the sun-centered system. However, mathematical details and proofs were still missing. He shared this text only with a few trusted friends. Reactions were mixed. Some were excited, some were shocked. In COPERNICUS, he summarized his revolutionary ideas. Earth is not the center of the universe. The sun is at the center. Earth and other planets revolve around the sun. Earth's daily rotation creates the day and night cycle. Stars are very distant and motionless. These ideas were incredibly radical for that time. For thousands of years, people had believed Earth was the center of the universe. Aristotle's physics theory, Ptolemy's astronomy model, the religious understanding of that era, all supported the Earth-centered universe. Copernicus was challenging all these authorities. Some clergymen in Frombork were suspicious of Copernicus's ideas. Gossip began to spread. Some attempted to accuse him of heresy. However, Copernicus acted carefully, did not enter open debates. He continued working quietly. However, he hesitated to openly publish his ideas. There were several reasons for this. First, he had not completed his mathematical proofs. He needed to support the model with detailed calculations. Second, such a radical theory would create great controversy. He worried about the Church's reaction, the academic world's criticisms. He thought about Giordano Bruno's fate. For the next 20 years, he continued writing his main work. De Revolutionibus Orbium Coelestium, meaning On the Revolutions of Celestial Spheres, was a large and complex study. Mathematical calculations, geometric diagrams, observation data. He prepared everything meticulously. Years passed, his hair grayed, but he did not give up. During this period, he had various duties in Frombork. He managed the cathedral's financial affairs, treated patients, played a role in administrative matters. Between 1516 and 1521, he administered Olsztyn Castle. During the 1519 to 1521 Polish-Teutonic War, he served in defense organization. Even during wartime, he did not neglect his observations. In 1519, he wrote a thesis on monetary reform. This work, titled On the Value of Money, made an important contribution to economic theory. Copernicus was one of the first to formulate the principle known as Gresham's law. Bad money drives out good money. This work showed he was not only an astronomer, but a versatile thinker. In the 1520s, Copernicus's astronomical theories slowly spread to wider circles. Some scientists began to take interest in his model. However, most were still skeptical. The sun-centered system seemed illogical, contrary to common sense. If Earth is moving, why don't we feel it? They asked. Martin Luther harshly criticized Copernicus. This fool wants to overturn the entire science of astronomy, he said. According to him, the Bible says Joshua stopped the sun, not Earth. Even the Protestant reformer opposed Copernicus. Copernicus completed his main work in 1530, but did not publish it. He kept it in manuscript form. His friends encouraged him to publish, but Copernicus was hesitant. He was aging, his health was deteriorating, but he still could not overcome his reservations. Perhaps he lacked courage. Perhaps the timing was not right. Tiedemann Giese was one of Copernicus's closest friends and constantly supported him. Giese was also a bishop and one of the rare people who understood the value of Copernicus's theories. For years he encouraged Copernicus to publish his work, but was unsuccessful. In 1539, a young mathematician, Georg Joachim Rheticus, visited Copernicus. Rheticus came from the University of Wittenberg and wanted to learn Copernicus's theories. He stayed in Frombork for 2 years and studied under Copernicus. The young man's enthusiasm impressed the old scientist. Rheticus was not only a student, but also the person who helped Copernicus overcome his psychological barriers. First, he gained Copernicus's trust, learned his theories in depth. Then he implemented a strategic plan. In 1540, he prepared a short summary called Narratio Prima and published it under his own name. This summary explained the main outlines of Copernicus's theories, but the author was not Copernicus. Rheticus was thus testing possible reactions. When the work was published, it was unexpectedly well received. Some scientists greeted it with excitement, some criticized it, but the anticipated big scandal did not happen. This success created a change in Copernicus. Perhaps the reaction would not be as bad as he thought. Perhaps there were supporters who would defend his ideas. Rheticus did not miss the opportunity and increased his pressure. Copernicus's aging and increasing health problems also created a sense of urgency. If he did not publish now, this knowledge could be lost forever. In 1542, Copernicus finally overcame his fears and allowed his main work to be published. This decision was the result of an internal struggle lasting more than 20 years. Rheticus took the text to Nuremberg and prepared it for printing. However, Rheticus was appointed to another position, and the work was taken over by Lutheran priest Andreas Osiander. Osiander added an unauthorized preface to the text. In this preface, he claimed the theory was only a mathematical calculation tool, not reflecting reality. Osiander was thus trying to soften possible church reaction. However, this distorted Copernicus's intention. If Copernicus had learned this, he would have been very angry. De Revolutionibus was printed in 1543. When the first copy reached Frombork in May, Copernicus was on his deathbed. He had suffered a stroke, and his state of consciousness was uncertain. According to legend, he held the book in his hand, but whether he read it is unknown. He died on May 24th, 1543, at 70 years old. He was a man who had devoted most of his life to this work, but could not see its result. Copernicus's death was only the beginning of his theory's long and turbulent journey. Initial reactions were mixed. Some scientists appreciated the model's mathematical value. Some were disturbed by the radical ideas. The church did not react at first, because the work was technical and difficult to understand. However, over time, the Copernican revolution gained momentum. Tycho Brahe made more precise observations. Johannes Kepler discovered that planetary motions were elliptical and developed the Copernican model. Galileo Galilei made observations with a telescope and found evidence supporting Copernicus. In 1616, the Catholic Church placed De Revolutionibus on the index of forbidden books. The sun-centered system was now seen as a danger because it contradicted biblical interpretations. The ban lasted until 1758, but it was already too late. The idea had spread, the seed had been planted. The Copernican revolution created fundamental change not only in astronomy, but in all science and philosophy. The human-centered understanding of the universe was shaken. The scientific method was strengthened. Observation and mathematical proof became weapons against authority. The man who once seemed timid and fearful had actually started one of history's boldest revolutions. Modern physics developed after Copernicus. Newton's law of universal gravitation, Einstein's theory of relativity. All of these are continuations of the revolution Copernicus started. If Copernicus had not overcome that fear, the history of science would have been very different. Copernicus's legacy is not only scientific, but also philosophical. He redefined humanity's place in the universe. He taught humility. Earth is not special, just one of billions of planets. This perspective lies at the foundation of our modern worldview. This is Nicolaus Copernicus's story, the epic life of a scientist who moved between courage and fear, defended scientific truth against authority, and laid the foundations of modern astronomy. The legacy of a man who did not give up despite difficulties, who persevered. If you enjoyed this narrative, don't forget to like and mention in the comments which other scientists' stories you would like to hear. See you in the next video. Goodbye.